Good evening, all. Welcome to the week two session for the course Matlab-based programming lab in chemical engineering. Let's wait for like 3-4 minutes so that more students can join, and then we'll start the session. So let us begin today's session. So this week we'll be discussing about the primer, MATLAB primer. That is, we'll be trying to write some basic codes in MATLAB, and we'll go through some example questions, so that this will form the base for the MATLAB programming for the rest of the course. So in case you have any doubts or something, you can ask me. And I've also believed that you guys have gone through the recorded lecture that has been shared to you through the NPTEL website. So if you have any queries, any doubts regarding that, also you can ask me during this session. So we'll go slowly. We'll first go through some basic syntaxes and some basic program writing in MATLAB, and then we'll go to the following problem solving sessions. Okay. I hope I'm audible. In case I'm not audible, or in case there is a network issue, please stay in the same meeting. Okay, and just let me know through the chat box. So this week we'll be getting initiated with MATLAB. We'll be discussing about few key parts of MATLAB, such as how to treat vectors, matrices, and we'll be doing some arithmetic operations. And then we'll be using some programming skills also, improving on some programming skills also. So before just going into the main part, this is where uh, this is an example that has been shared to you during the recorded lectures. But before going to that, I'll just briefly show you how to treat the vector matrices and vectors in MATLAB, and how to do mathematical operations with them. So just give me a second. I hope I'm sharing the MATLAB screen, and I hope you guys can see it. So earlier last week, I had given you a brief understanding of how the MATLAB looks like. I'll just repeat it once again very quickly. So here you have like different tools for working with MATLAB. So here you can see new. This is where you start a new MATLAB script or a new MATLAB function. You can also open some existing files if you want, and this is how you save it. So when you're saving it for the first time, you have to use save as, and all MATLAB files comes with a .m extension. So you can see here I have several MATLAB files written. You can see all the MATLAB files has a .m extension to it. So just a second. So here you can see every MATLAB files have a .m extension to it. And now, so this portion is called as a current folder. Here you can see which folder you're currently working in. And the same path can be observed here also on the top line. So I'm working here on my desktop. I have a folder called as CHC programming and then week 2. So this is the current folder which I'm working in. So whenever I open, so MATLAB usually this you have a command window. Here you can enter the commands you want, just like 1 plus 2 equal to 3. So here you enter the commands and you get the answers. If you don't put a semicolon, so if you have just 1 multiplied, so 1 plus 3, and if you put a semicolon, you will not get the answer printed out like this. Okay. But you will have the answer here. So what if you don't have a variable assigned to your operation, MATLAB automatically take ANS as a variable and the value for ANS can be seen here. So this is called as a workspace. Here you have the list of all the variables that you will be using and also the associated value of it. Okay, so here answer is equal to 4. So I'm writing A is equal to uh, 4 multiplied by 5 and I put a semicolon. It will not be printed here because the output is suppressed whenever I'm adding a semicolon at the end. But you can see here the variable pops out. So variable A is the value is 20. So this is a workspace. This is a command window. As soon as I open a file, so if here I'm opening v2.m, you will get a window like this. So this is the editor window. As you can see, this is the editor window. In the editor window, you will be able to see your MATLAB scripts and MATLAB functions. Okay. And briefly, I'll just quickly tell you what is the difference between MATLAB scripts and MATLAB functions. Scripts is when you have to repeat a certain set of commands. Okay. So then you'll have to use a MATLAB script. MATLAB function is when you have to take certain inputs, do a set of functions, and if you have to give an output. Okay, if you have to take input from the user, or else if you have like different subroutines. So from one subroutine, you have a certain values that has to be taken to the second subroutine. So when you have transfer of variables or something, then you use a function. If you just have to repeat a certain set of commands repeatedly, then you use a script. Okay, so that is the basic difference in MATLAB script and MATLAB function. So here, before starting that, I'll just show you how to write MATLAB vectors, matrices, and all those things. Okay. So many people might know it. For those who don't know, it will be just a quick recap to the MATLAB course. So if you want to clear the workspace, you use clear command. So here you can see the workspace getting cleared. The workspace got cleared. If I want to clear the command window, I use CLC. So here my command window got cleared. Okay. So this is how a general vector looks like in MATLAB. You start with a variable vector name and then you have an open bracket, a square bracket where you enter the values. If the values are separated by a space or a comma, then it is called as a row vector. So here, and if the values are separated by a semicolon, then it is called as a column vector. So so here you can see percentage sign in MATLAB means comment. Okay, this will not be executed. This is just for our knowledge, just to understand what this code is doing all about. Okay, so it's always advised that you write comments when you are writing a MATLAB code. That is because after like maybe weeks or months later, when you come back to the code, you will have an understanding. Okay, this is what I'm doing in this code, or else there is a high chance you might forget it. Okay, so write comments. And if I'm putting like two percentage signs nearby, then it forms a MATLAB section. Okay. So that is why you can see this blue line. This is the section. It has separated this percentage sign and this percentage sign. Between it, it forms a section. So if I want to run the section alone, just click somewhere on the section. And then you can see here there is something called as, just a second. Okay. So here there is something called as run section. So just click on run section. Here you will see V is a row vector and W is a column vector. Okay. Now, if I want to take a transpose of a vector, this is how you do it. So V is a row vector right now. Now let me do the transpose. So just click on this column and I'm using run section. So you can see V is a row vector and the transpose of it, you will get a column vector. Now, vector means you only have one dimension, either a row or a column. Okay. Now we have matrices. So matrices means you have like two dimensionals. You have a number of rows and number of columns. How do you enter the matrices? So first you will have to start with a square bracket. Then you will enter the values which belongs to the first row. And that values has to be separated either by space or by commas. Okay. So this forms my first row. Semicolon means I go to the next row. This is my second row elements. Semicolon again means I go to the third row. These are my third row elements. Okay. So now I'll just run this. If you want to just run this command, just select this command and uh, on the mouse, on the press the left key, then you will get this. Okay. You will have to click on the first one, evaluate selection in the command window. Okay. Then you will see only this gets executed. So now this is your matrix. That is 1, 2, 3, first row, 4, 5, 6, second row, and 7, 8, 9, the third row. Now, if I have to, so whenever you're declaring something, whenever you're creating a matrix, whenever you're creating a vector, okay, when you're declaring it, you have to use a square bracket. But when you're further trying to use a value of it, okay, when you're trying to call a value from it, then you have to use a round bracket. So if I want to extract the second row first element. So this is my second row. First element means it will be the fourth one. So first I have to give the row number followed by the column number. This order is very important. First to use the row number and then the column number. So A21 means I get the value 4. Okay. Now imagine I want to replace a value of this matrix. So I want the third column element to be 0. Right now the third row is this. Third column means it will be value will be 9. I want this 9 to be replaced by 0. How do you use it? You first get access. That is A33 means this is the space. I make it equal to 0. So I'll just run this command for you. And now you can see this 9 turned into 0. A is 1, 2, 3, 4, 5, 6, 7, 8, 0. So this is how you substitute an array entry. So when you are trying to access a particular element of an array, you have to use a round bracket. But whenever you're creating an array or creating a vector, you have to use a square bracket. Now, if you have to access certain, so this is just for accessing one element of the matrix. But what if you have to access certain elements, okay, and a set of elements from the array? What do you do? For example, imagine this is my vector. Okay, I'll just evaluate the selection. So this vector has 1, 4, 7, 10, 30. Okay. Now I want to extract only the first three elements of this vector. So how do you do it? To access the element, you have to use a round bracket. So this colon operator, okay. 1 colon 3 means, okay, this is a basic MATLAB column which you have to understand how this works because this simplifies a lot of your coding. Okay, so 1, 2, 3 means it will be starting from 1. It will be incrementing the value by 1. That is, it will start from 1. It will take a step of 1 till it reaches 3. So it will be like this. It is 1, 1 plus 1, 2, 2 plus 1, 3. Okay, for example, 1, comma 5 means it will be 1, 2, 3, 4 till 5. Now, if this increment by default, MATLAB takes the step size is 1. Okay. But what if I want to increment by a step size of 2 or 4 or 5? What do you do? I do 1 colon 2 comma 10. That is, I want to start from 1 up to reach till 10, but with a step size of 2. So it will be like this. The first value will be 1, then it will be 1 plus 2, 3, then it will be 3 plus 2, 5, and then it will be 5 plus 2, 7, and 7 plus 2, 9. And 9 plus 2 is 11, okay, which goes beyond this 10. So that is why you will not get that element. So you'll have the starting value and the ending value. It will be between this limits. This is the lower limit and this is the upper limit. And the step size taken will be this. Now I can do the reverse also. Like I want to go from 10 to 1, but I have to use a step size of minus 2. So see, it will be 10, minus 2, 8, minus 2, 6, minus 2, 4, and minus 2, 2. Now 2 minus 2 is again 0, which will be beyond this limit. Okay, so the 0 will not be printed. So you'll have from 10 to 2. Is this clear? Any doubts? If you have any doubts, please to stop me and you can maybe unmute yourself and ask also. Okay. So this is how this colon operator works. So now if you want to access a certain part of the vector, what do you do is, so this is your vector. Okay. If I want to access the first three elements, then you have to give the indexes of the first three elements. So the index is 1, 2, 3. So how do you do it? You have to evaluate this command. That is I have to take the index. Index should be there in the round bracket. So it will be V1, 2, 3. So basically, whatever the 1, 2, 3 is there, this is this one. That is 1, 4, 7. First index, second index, and the third index. Now, if I want to get it from the third index to whatever the last index is, okay, imagine I don't know what the last index is. Then MATLAB has a keyword which is called as int and automatically calculates what is your last element in your array or vector is. Okay, so this takes from 3, 4, 5, like whatever the last index is. So it will be 3 is this, then 10 and 30. So final answer will be 7, 10, and 30. Okay. Now, if you want to convert this into a column vector, this is another option also. You can just, instead of taking this transpose, you can also do this. Okay. B in the bracket, you can give column. Now, if I want to take the full elements, okay, then it can be like this. Okay. 1 to end means from the first index to the last index, every index it will be extracted. So basically, you'll get V itself. That is 1, 4, 7, 10, 30. So this is how you access a block of elements. Okay. I hope this colon operator I've already explained. So this is like from 0 to 5. I'll take a step size of 0.1. You can see that here. So 0, 0.1, then 0.2, 0.3, till the last value is 5. So this is how the colon operator works. Okay. Now the same thing, let us extend to a matrix. So a matrix, you can see this is a matrix, a 3 by 3 matrix. Now I want to extract only the second row, but all the columns. So second row, all the columns means this is my second row. This is the first column, second column, third column. So I want to extract 4, 5, 6. Okay. So this is like, you do it like this. So A, you first mention the row number. Sorry, you first mention the row number, that is 2. Then colon means everything. Okay, colon is means when you're just putting the colon, it means that you're extracting everything. So if colon comes in the if the colon comes in the column space, okay, the second space is the column space, it means that you're extracting all the columns, all the columns. Okay, so let me just execute this. You'll get row to all the columns. That is 4, 5, 6. Now I want all the rows, but only the 2 and 3 columns. So it will be like this. This means all the rows. So all the rows means all the rows are there, but only the second and third column. That is, this is second column. This is third column. That is 2, 5, 8, 3, 6, 9. 2, 5, 8, and 3, 6, 9. Okay. Now, if I want to delete a column, how do you do? This is A. This is semicolon means all the rows, but the second column, but empty means I'm trying to delete it. Okay. This is a null vector. Okay. I'll show you like this. So imagine first your A was this 1, 4, 6, 2, 5, 8, 3, 6, 9. Now I deleted the second column. Okay. Now it will become 1, 4, 7, 3, 6, 9. So 1, 4, 7, 3, 6, 9. So this is how you access. Okay. So now we have seen how the colon operator works. Apart from colon operator, you can also generate a vector using this MATLAB command, which is called as linspace. Okay. So in linspace, what you do is you have a point, starting point, you have an ending point. So I'm starting from 0 and my last value is 2 pi. And I have to create 101 equally spaced points between this. Okay. So now if I just run this command for you, see, so starts from 0 and this 6.2832 is 2 times pi. Okay. Now how many values I have? I have 101 values generated. And this points will be equidistant. Okay, so in case you have to generate a large number, for imagine that you have to create generate some numbers from 50 to 100. You have to create maybe 200 points or something, and it has to be equally spaced. Then you don't have to worry about how much step size you should take to get equal space points. That will be automatically done for you. So if I want values from 10 to 100, I put 10 here, I put 100 here, and if I want 100 equally spaced points, I write 100 here. Okay, so this is the lower limit. This is the upper limit. This is the number of points that has to be generated, and it will be equally spaced. That's how this linspace command has been coded. Okay. So I hope this is also clear. Now, how to access the dimension. Okay. Now, how to access the dimension is, so you have a vector like matrix like this, which you have already declared earlier. Now, there is a MATLAB keyword, which is called a size. So size means it will give you the row number and the column number. Okay. So size A means the first answer you get will be the row number, and the second answer you get will be the column number. So imagine that I am using this command. Okay. I'm making A like this. So this is my A. Now what will be my size of A? My size of A will be 3 rows and 2 columns. Okay. So this is how the size A works. Now if I want to, right now it will be saved in the answer. Okay. So ANS is the default variable given for the answer. What if I want to save it? Okay. This might be useful when you're creating loops or something. So when you want to save the number of columns, number of columns and number of rows, this is how you do it. You do m dot, okay, you save like this. So here m will save the first value, so that will be 3, and n will save the second value, which is a column number, that will be 2. So you will have m rows and n columns. So this is how you save the values if you want to. Okay. Now, if you want to specifically get only the row number and the column number, you don't want it together. You only want to extract the row numbers and you only want to extract the column numbers separately. So then you use size a comma 1. 1 means the first dimension. Okay. First dimension is always a row dimension. Okay. A comma 2 means 2 is the second dimension and column is the second dimension. So here you will get it like this. This will give you the number of rows, which is 3. Okay. And this will give you the number of columns, which is 2. Okay. So you get 3 and 2 as an answer separately. If you want to do it separately, not get together like here, you can do that separately also. Now, how to concatenate? Concatenate means you already have a matrix. How to keep on adding matrices? Okay. So for that, I'll just first make this A matrix. This we already know. This is 3 by 3 matrix, which we have been using throughout. Now you want to add matrices. So for the matrix, it has to be added in such a way that you have this matrix A, and on this side, you want to multiply all the elements by 10 and keep it on this side. Okay. Now below you want a matrix where all the elements of A is, you have multiplying it by -1. Okay, you want it here. And then you want an identity matrix on the other side. How do you create it? You have to write it properly in an order. Okay, so this is a matrix. And in the same row you required, same row means in the same horizontal direction you require 10 times A. That is, every element of A should be multiplied by 10. And then you're putting a semicolon. Semicolon means you're coming in the vertical direction. You're coming down below. It has to be minus A. It means every element of A should be multiplied by -1. And then in that same horizontal direction, so here minus A is here, in the same horizontal direction, you need an identity matrix. So now finally your B will look like this. See, it is 1, 2, 3, 4, 5, 6. This was your A. This is 10 times your A. And this is minus times your A. And this is your identity matrix. So this is how we concatenate, or this is how you keep, you stick one matrix to another and make a final matrix together. Okay. So this is concatenating matrices. Next, we have some inbuilt matrix generators in MATLAB. Okay. Once means it will generate. So there are some, if you want, you can just go to help and you can see help I. Okay. So you can see what I does. I creates a n by n identity matrix. Okay. Likewise, if you have doubt, you can just type the keyword and use a help command. Okay. You'll get the answers. So how do you use it? B ones means you will be getting all ones. Entry will be 1, but you have to mention the size. So size is a 3 by 1 matrix. So B will be like this. B will have 3 rows and 1 columns. All entries will be ones. Okay, so this is an inbuilt matrix generator in MATLAB. Now I have to create a 3 by 3 matrix. Okay, of everything is 1. Okay, then I have to only mention one index. If I only mention one index, MATLAB will consider it as a square matrix. Okay, which means it will be, if I give 3 as a number, it will create a 3 by 3 matrix. If I create I bracket 4, MATLAB will be like, okay, it's a square matrix and it will be 4 by 4. Okay, so now I3, you'll be getting like this. Okay, sorry, identity, I is identity. Okay, ones is all ones. So you'll be getting an identity matrix 3 by 3. Okay, now if I want to create all zeros, and it has to be 2 rows and 3 columns, it will be like this. It will be 2 rows and 3 columns. The keyword is zeros. It means that all your entries will be zeros. Now imagine I have a vector matrix like this. Okay, this you can see that I have to use the same concatenate. I have a 2 by 2 zero matrix, an identity matrix of 2 by 2, sorry, one vector matrix of ones, which is 2 by 2, and an identity matrix of 2 by 2. So you'll see this being concatenated. I'll just run this here. See, this is the first matrix you gave 1, 2, 3, 4. Then you have a 0, 2 by 2 zero matrix. That is a 2 by 2 zero matrix here. Then you have a 2 by 2 ones matrix here. And you have a 2 by 2 identity matrix. So this has been concatenated into a single matrix D. Okay. Now coming into arithmetic operations. So these are the basic things. If you have a matrix like this, okay, the matrix sizes has to match. Only then you can do arithmetic operations. So you have a 3 by 3 A matrix, 3 by 3 B matrix. A plus B means it will add all the elements for you. Okay, it added each and every element. So 1 plus 10, 11, 2 plus 20, 22. So you'll get 22, 11, 22, 33 like that. Okay, and uh, a multiplied by B means it has to follow the matrix multiplication rules. So I hope that you know the matrix multiplication rules. So that is, if you are multiplying A and B vector, A and B matrices, the column number of A should match the row number of B. Okay, that is when you can do a matrix multiplication. That rule has to be satisfied. Only then you'll get an answer. Otherwise, this command will show an error for you. Okay, so this you'll get a matrix multiplication. Okay, all the rules of matrix multiplication is applicable here in A star B. Now, if I want to do A star A itself, okay, then you can do either A star A or you can do A exponential 2. Okay, this is similar to A. I'll just show you. This is similar to A star A. So here, see, this is A raised to 2. Now we'll see what is A star A. See, these both are the same. So this is A raised to 2 means A multiplied by A itself. A raised to 3 means it will be A multiplied by A multiplied by A. Okay. So it is similar. The answer is the same. Now, what if we want to do element-wise addition, element-wise multiplication? Okay. So that is right now, this is A multiplied by B. Okay. Now, what if I want to multiply? Let me just show you A and B once again. Okay. Now, what if I want to multiply 1 with 10? 2 with 20, 3 into multiplied by 30, 4 multiplied by 40, like that. That is, the 1 element of A will be multiplied with the 1 element of the B. Okay. Likewise, if I want to do element-wise multiplication, before putting this star sign, you have to put a dot symbol. Okay, dot star. So this will do element-wise multiplication. I'll show you here. See, this is 1 multiplied by 10, 2 multiplied by 20, 3 multiplied by 30, you get 90, 4 multiplied by 40, you get 160, 5 multiplied by 50, you get 250. So this is element-wise multiplication. Okay. So this also will be element-wise multiplication. This is the A itself, the elements of A itself will be multiplied by elements of A. Okay, it's not matrix multiplication. Please keep that in mind. When you put a dot sign, it is not matrix multiplication, it is element-wise operation. Okay, so it will be 1 multiplied by 1, 2 multiplied by 2, 3 multiplied by 3. See, 1, 4, 9. Okay. Now, if you want to do element-wise division also, you can do it. Okay. Now, each element of A is divided by 2. See, you get it like this. So these are element-wise operations. So for element-wise operations, you have to put a dot symbol. Now, this is some standard matrix formula. When you have a matrix like this, okay, okay, you have a matrix like this. If you want to calculate inverse of a matrix, there is an inbuilt MATLAB command that is INVA. It will calculate the inverse of that automatically for you. And this DET is for calculating determinant of it. So this is a determinant and this is the inverse. Automatically it calculates for you. Okay. Now if you have a vector like this, you have some inbuilt commands like sum. Okay, sum is a MATLAB inbuilt command which will add the elements for you and it will become 3 plus 2, 5, 5 plus 1, 6. Okay. Cumulative sum means it will calculate 1, then 1 plus 2 will give you an answer, then 1 plus 2 plus 3. That is cumulative sum. So you'll see how this cumulative sum works. We'll be getting answers as the first element 1, then it will become 1 plus 2, it will be 3. Then 1 plus 2 plus 3, it will be 6. Okay, this is the cumulative sum. The same is applicable for products also. Product means it will first calculate the product of all the elements. So it is 1 multiplied by 2 multiplied by 3, again 6. Cumulative product will be, it will be 1 multiplied by 2, 2. Then 2 multiplied by 3, that is 6. So 1, 2, 6. So this is the cumulative product. Now we have something called as rank of a matrix. So if you don't understand what rank of a matrix is, rank is the number of independent rows or independent columns you have. If you have more doubt, you can just Google it and see. It will be the number of independent rows and independent columns. Okay. So here you can see here, you have 1, 2, 3, 3, 6, 9. Okay. You can see that none of the rows are actually related. Yeah, actually this row multiplied by 3 is this row. Okay. If you want to calculate rank of a matrix, you don't have to use your brain so much. You have the inbuilt MATLAB command rank, and it gets you 1. Okay. Uh, okay, that is because you can see this row, okay, this column 1, 3. If you multiply it by 2, you get the second column. That is 2 and 6. If you multiply it by 3, you get the third column. So basically, you can write this column as a function of the first column. You can write the third column as a function of first column. So basically, how many independent columns you have? You just have one independent column. Other two other functions are the first one. So the rank is equal to 1. Okay. Now imagine I have a matrix like this, the identity matrix. In this identity matrix, you can't write a row or a column as a combination of other two rows or columns. So in this case, the rank will be 3 itself. See, the rank is 3 itself. Okay. Now there are some other things like diag. So if you have a function, if you have a matrix like this, I'll just show you here. So if you have a vector like this and you want to create a matrix, okay, you have a vector like this, and I have to create a matrix whose diagonal entries are this 2, 1, -1, -2, -5. Then I can use this function, diag. Okay, diag will create a matrix like this for me. Every entries will be 0, but except the diagonal entries will be the vector that I give, the V vector that I give 2, 1, -1, -2, and -5. Okay. Now this when I give just diag V, this will be placed on the main diagonal. Okay. If I want to keep it in the lower diagonal, that is here in this point. Okay, lower diagonal. Then I can give here -1. -1 means lower diagonal. 1 means upper diagonal. Okay. So I'll show you here. See, now this is the main diagonal. Zeros are on the main diagonal. This is the lower diagonal. Okay. Now the same thing if I type here +1, you will see the upper diagonal entries will come and the main diagonal will be zeros. Okay. And this is one thing you can do. Now, if you have a matrix like this, okay, rand means it will create a matrix. Rand 6 means it will create a 6 by 6 matrix whose all entries are random numbers. Okay. So this is a random matrix and I want to extract only the diagonal entries. So that will be like this. I have to use a diagonal, same diag command itself, but here the input is not a vector, but instead a matrix. Then it will extract the diagonal vectors for you. So 0.8986, 0.5487 like that. Okay, it will extract the diagonal entries for you. So these are some inbuilt commands. And now if you want to take the input from a MATLAB code, this is how you do it. Input is a keyword. I'll just run this section for you. Okay, the run section. So it is asking me. So input, whatever is there in the codes will be printed. Okay, you can see that. Now he can enter the value here. Enter the points code in the first game. I'm typing 10. Now the next command is executed. Enter the points code in the second game. I'm writing 20. Okay, next is enter the points code in the third game. I'm writing 50. Okay, now automatically the average is calculated. Average is the value of the first one, second one, and third one divided by 3. And this is the output command in Matlab display. It will display the average score is then this average, no, this number is a numerical data, right? So for printing, the numerical data has to be converted into a string. So for that in Matlab, we have a function which is called as num to str. That is numerical thing to a string function. Okay. So num to str, this average that numerical data will be converted into string and it will be printed for you. So the average score is 26.6667. Okay. So these are some basic things in MATLAB. Have you understood this? Do you have any doubts?
No, ma'am.
Yeah. Okay, fine. Now I have actually codes for showing control flow also. That is, I have codes for showing you how if else if statement works and how the loop works.
Excuse me,
Do
ma'am.
you? Yeah, sure.
Ma'am, in concatenation, when you talked about concatenation, is it necessary that all the matrices that we are concatenating should be of the same size?
Yes. And same size means if you're adding a matrix in the horizontal direction, okay. So imagine I'm adding a matrix in this direction, okay. Then the number of rows should match. Okay, whichever dimension you are placing it, that dimension number should match. So if I have 3 rows here, if I'm placing a value here, that should also have 3 rows. Okay. Number of columns, you can have any number of columns, but the row dimension should match. Now if I'm placing it below, Okay, that is in the column dimension if I'm placing it, then the column number should match. It can have any number of rows, but the column number should match. Okay, did you understand or should I show it to you with an example?
No, ma'am, I've got it. Thank you, ma'am.
Yeah, okay. Okay, now I don't know if there is enough time for us, but anyway, I'll just quickly show you many might know it. Okay, so this is how the control flow works. Okay, we have if and else command in MATLAB. So here you have a condition. Okay, this is how to calculate if the discriminant is negative, roots are imaginary. This you've seen in Max, right? You just calculate b square minus 4ac, and you just decide whether you have like an imaginary root, if the roots are repeated or the roots are real. Okay. So this thing you've already seen. So that's what I'm doing here. I have three variables for A, B, and C. I'm calculating the discriminant as b square minus 4ac. Then I'm using if discriminant is less than 0, then I'll display this. Discriminant is negative, roots are imaginary. Okay. If this condition is not satisfied, I go to the second value. Okay, that is else if. So else if means discriminant equal to 0. These are like logical state, logical argument, logical what you say, simples. Okay, this is greater than, this is equal to, which means checking if both the values are equal to 0. If discriminant is equal to 0, then I display discriminant is 0, roots are repeated. Okay. If none of this satisfies, then I go to the else statement. Okay. Then it prints roots are real. Okay. So when you're writing a control flow, you can just have one if statement and you can end it. Every if statement requires an end statement. Okay. That is very, very important. But if you have multiple conditions to be checked, like here, you have to check whether it's less than 0, have to check whether it is equal to 0. If you have multiple conditions to check, then you can put down multiple conditions in else if, else if, else if. You can have any number of else if commands. Okay. Now, if you have one condition, if that condition is not true, you have an else condition. Okay. Then you can skip the entire else if, and you can only have if, else, end. Okay. This you can design according to your need. But the highlight is wherever you use the if statement, you have to end it. Okay. If and this end command comes together. It comes as a package. Okay. That is very, very important. Okay. And remember, only if this condition is true, this will be executed. Okay. If this condition is false, it will go to the second condition. And if this condition is also false, it will go to the third condition. Okay. That is how the control flow happens. So that is how an if statement works. Now I'll show you the basic loops in MATLAB. We have a for loop and while loop. Okay. Which we more often we use these two kinds of loops. Let me just clear all this. Yeah. A for loop. So there might be a question. Okay, when do I use a for loop? When do I use a while loop? Okay. For loop you use when the user knows that I have to repeat a certain set of commands these many number of times. Okay, I know the number of times it has to be done. Okay. If that is clear to me, then I use a for loop. Okay. When do you use a while loop? While loop can be used when I don't know how many number of times I want to run. Okay. But the loop has to stop when some condition has been met. It can run for any number of times, but I have to stop running when some condition is met. When you have a condition known, then you use a while loop. If you have the number of times known, then you use a for loop. Okay. For example, here I want to run the for loop from I equal to 1 to 5. That means I have to run the loop 5 times. Okay. Then I use for. This is the syntax of using a for loop. Okay. For I equal to 1 to 5. This means in the first loop, I is equal to 1. Okay. It goes inside the loop. It executes it executes this command and it goes again to the top. Then I takes the second value. So after 1, it is if you remember, this is 1, 2, 3, 4, 5. Colon operator increments from 1 to 5 with a step size of 1. Okay, so it will become 1, 2, 3, 4, 5. So basically, this is how you get it. I can just show you here. So first, I value is 1. X is 1 multiplied by 1, 1. Okay. Next, this I'm just saving a values here. Okay, that I'll show you later. Now, I value takes 2. Then X is 2 multiplied by 2, 4. If the next one I value is 3, then is 3 multiplied by 3, 9. Okay. Next I value is 4. 4 multiplied by 4, 16. And the next one I value is 5. 5 multiplied by 5, 25. Okay. So I have repeated the loop 5 times. So if this number is known to me, then I can use a for loop. And here you can say I've also made a vector to store this X values. So what I did is I created a vector A. And in that, I'm taking the first I value should be 1 multiplied by 1. So you'll be getting a vector like this. 1, 4, 9, 16. Whatever answer I have here will be saved here. Okay. So here it will be I1 is 1 multiplied by 1. I2 is 2 multiplied by 2. I3 is 3 multiplied by 3 and so on. So this is the same for loop we can use in the reverse order. So this was incrementing from 1 to 5. This will be decrementing from 10 to 1 with a step size of -2. I'll just show you this one also. Yeah. See, so it went from 10. So 10 multiplied by 10, 100. Then 10 minus 2 is what? 8. Then 8 multiplied by 8, 64. Likewise, it goes till, I think it goes till what? 4, 2. Yeah, 2. It goes till 2 only. So it will become 2 multiplied by 2, 4. So this is when you use a for loop, when you know the number of times a certain command has to be repeated. Okay. But on the other hand, while loop, if you see, so here I'm starting with a while loop. You have to initialize the variable that you use in the while loop before starting the while loop. Okay. So I'm telling that my looping variable is y, and my y initially it is equal to 1. And I check a condition. Is y less than or equal to 10? Okay. Yes, my condition 1 is less than or equal to 10. So I enter into the loop. Then what I do is y is equal to 3 multiplied by y. Now y value is 3. Okay. It again checks the condition. Is 3 less than or equal to 10? Yes, I'm right. Then I again evaluate, go inside the loop. Likewise, I go until and unless this condition become false. Okay. So here I type, I can see, okay. So first y value is 1, then 1 multiplied by 3, 3. Is 3 less than 10? Yes, I'm right. Then again I go, then 3 multiplied by 3, it's 9. Is 9 less than 10? Yes, I'm right. Again I go to the top, 9, and then I type, then I get this value, 9 multiplied by 3, 27. Is 27 less than 10? No, I'm not. 27 is not less than 10, so it automatically exits the loop. Is this clear? Okay, I hope
Ma'am,
this is
can you
clear to
repeat
Yes,
you.
ma'am.
while loop again?
Okay, while loop means you have a first condition. So first I'm declaring y is equal to 1. Okay, then it checks the condition that has been written here. That is y less than or equal to 10. So first I check, is my y less than or equal to 10? Okay, but obviously 1 is less than or equal to 10. So I enter into the loop. Okay, then here I type the new y value is 3 multiplied by y. Here y is 1, so it becomes 3 multiplied by 1, which is 3. Again, it goes to the first line. Okay. Is 3, now my new y value is 3. Okay. Is 3 less than or equal to 10? Yes, it is. It again enter into the loop and it will be getting 3 multiplied by, now the y value was 3, right? So 3 multiplied by 3, you get 9. Again, you go to the loop. Is 9 less than or equal to 10? Yes, it is. Now my new y value is 3 multiplied by 9. That is 27. Now again, I go to the top. Is 27 less than or equal to 10? No, it is not. So it exits to directly to the end statement. It comes here. Okay. Is it clear?
Okay, ma'am, clear.
Yeah. Okay. So that's how a while loop you use. These are just simple examples. So you'll have to use for loop or while loop. You have to decide depending on your need. Okay. If you know a certain number of times it has to be run, you use a for loop. Or else if you know that, okay, I have to run it till a condition is met and then you use a while loop. So these are some uh, examples. Now I've shown you a simple example of how to use a function. Okay, this is what I said. If I want to give some inputs and if I want to get an output out of the code, then it is always better to use a function. So here the function is like this. You start with the keyword function, which tells Matlab, okay, this is a function, not a script. And then you start with the variables. So these are the output variables. Then you put the equal to sign. This is your function name. And in the round brackets, you give certain variables. These are the input variables. Okay, input arguments also you can call it. So this is a basic syntax of a function. You have the keyword, output, equal to, the name of the function, and in the brackets, you have the input. Then inside the function, you have certain set of commands that has to be executed. And the function always ends with a keyword end. Okay, and this output will be displayed here. So if you want, I'll just run and show you. How to run a function means you can just call the function and give the inputs. Okay, so this is the function's name. And instead of A and B, I should give some inputs. So it will be 2 and 3. See, you'll be getting S is equal to 5. Okay. So basically, one more thing I had to do, I had to suppress this right now. That is why it is printing twice. Now I'll write value is equal to add num 3, 6. Now what happens is 3 and 6 is taken. A takes a value 3, B takes a value 6. It will be added. It will be 3 plus 6, it will be 9. Okay, your S is 9. Okay, and here instead of S, I have used a different variable value, but that is fine. Okay, because value automatically takes the output here. So value will be equal to 9. It's not compulsory that you have to be using the same variable in the definition and while calling. You can use different variables also. That is completely fine. Okay, so this is how we use a function. Whenever you use a function, you give certain outputs. You give a certain inputs and you get a certain outputs out of it. Okay, I hope that is clear. Now what I'll do is I'll quickly go through the recorded lectures which sir has shown you. So here there is an example. I hope you can see here. So here you have a derivative example, dy by dx plus 2xy plus x is equal to e raised to minus x square. So this is like a ordinary differential equation. And you have said that y at 0 is equal to y at x is equal to 0 is equal to 1. So this is an ordinary differential equation initial value problem. That is at x is equal to 0, you know what the value is. After that, you don't know what the values of y are, but you know how y behaves. That is given by this formula. Okay. So how do you usually solve the ordinary differential equation? You can integrate it, right? When you integrate it manually, you can do it analytically, and then finally you'll get an answer like this. Okay, that is how y behaves as a function of x. Okay, so now x value, if you range from 0 to 1, you will get a y behavior like this. So x value you can give 0, 0 0.2, 0 0.4, 0 0.6 up to 1. You'll be getting y values like this. Okay, this is how you analytically do it. Okay, and there are also inbuilt functions in MATLAB that can help you with the ordinary differential equations. But right now, we'll just try to use a method which is called as Euler's explicit method. Okay, this is a method in mathematics that will help you to solve such problems. Okay, ODE problems can be solved using Euler's explicit method. Okay, here we will see how to code this one. Okay, the idea is very simple. The whole idea of solving an ODE is we need to know how the y is behaving as a function of x, right? So, and you know what the starting value of y should be. We know the starting value of y should be 1. See, starting value of y should be 1. And you need to know how the y is progressing. So what do you do is, this is a Euler's explicit formula. Okay, just imagine yn, that is what you start from, is equal to 1. And you need to know what is the dy by dx at that point, at the first point. Okay, at the starting point. Then you have a small step size for x. If you have that, you will get the next y value. That is yn plus 1. Okay, now what do? You put that yn plus 1 here. Okay, at the new point, you again calculate the gradient and you have a step size y, you get the y value for the second point. Okay, so that is you're progressing. So that is you start from here. Okay, this y value, you need to know the y value. I need to know the y dash value. That is a derivative information at this point you need to know. If you know these two values, you can calculate what's the y value here. Okay, at this point, you again calculate y value and y dash value. Using this, you calculate what is the y value here. Okay. Likewise, you take small step sizes. That is delta x. Small step sizes you take. And finally, at the end of it, you'll reach here. Okay. That's what you do in Euler's explicit method. You first need a starting value. And with the starting value, you get the next value. And with using this, you get the next value and so on. So how do you code it? So for coding it, you need to start with the x value. So x, I'm starting from 0. See, in the graph, I'm starting from 0. Now the y value. What was my starting y value? Starting y value is 1. See, my starting at x is equal to 0, my y is equal to 1. So my starting y value is 1. Now I have to decide a small step size, delta x. So in my code, that variable is h. I'm taking a small step size of 0.1. Okay, h is equal to 0.1. Now till what should I do it? Till what x should I do it? So my xt means when my last x should be 1. I'm doing from 0 to 1. Okay, xt is equal to 1. Sorry. Okay, now I have to keep doing this formula again and again and again. Okay, so for this, it is ideal that you use a while loop. So what will be the condition that you use in the while loop? The while loop condition will be, you have to start from the starting x, that is x is equal to 0. And I have to repeat this until my x reaches the upper limit, that x is equal to 1. Okay, Until that, I have to keep doing this. So what will be my equation? So my equation is, this is just for printing it, okay, for your sake. Okay, it is not computing anything. You will get the x and y value. Now we need to compute dy by dx. Okay, dy by dx, you directly get it from this formula. You can take this 2xy and x to the other side. So dy by dx is equal to minus 2xy minus x plus e raised to minus x square. So that is the formula. See, that is exactly what is here. Dy by dx, you first calculate, will be exponential of minus x square minus 2x minus 2xy minus 5. Okay, this thing you have to take to the other side. You calculate the derivative there. Okay, and then you use this formula. You have calculated this portion. Just a second. Yeah. So you have calculated in this one, you're calculating this portion. Okay. This portion has been calculated. Dx you already know, which is nothing but your h thing. Okay. Now you know what the starting value of 1 is. Starting value of y is 1. So everything is known to you. Now we can calculate yn plus 1. So yn plus 1, here it is given here. Yn plus 1 is equal to y0, that your starting value, h multiplied by dy. You get the next y value. Okay. Now you have to replace here. This x has to be replaced. Now you're taking the next x value. So x is equal to x plus h, and you replace this y with the new y value that you get. So y0 is equal to y1. Again you go. Okay, so from here again you go here. Okay, because your x is still less than xt. Again you calculate the dy. Again you take the increment. You reinitialize your x, reinitialize your y. You keep doing it until x is less than xt. Okay, is this clear or should I explain it again?
Ma'am, got you can proceed.
Yeah, you got it?
Yes, ma'am.
Yeah, fine. So now how do you do it is, since you got this, we'll just try doing it in MATLAB. Um, Let me just clear it. Clear. CLC. Okay. So this is a MATLAB code we have. So everything, whatever we have discussed is here. Okay. Now I'll just show you. Let me just check. For running, you can just go to the top and there is this run command. Okay. So basically, we started at x is equal to 0, y is equal to 1. Then you get at x is equal to 0.1. Why is it 0.1? Because incrementation is by 0.1 step. Okay. At x is equal to 0.1, y is equal to 1.1. At x is equal to 0.2, y you get as 1.16. At x is equal to 3, you get y equal to 1.19. Okay. Basically, since we have not put semicolon here, this gets printed like this. Okay. So this is a simple code using Euler's explicit method. Now you can just further complicate this code. Let me just show that. Okay. Okay. This also has been shown to you in the recorded lectures. I'm just repeating it once again so that if you have any doubt, you can just ask me. Okay. So here the whole code remains the same. Okay. Just that if you remember, you had this portion, right? By calculating the derivative, this portion. For this portion, rather than writing this, we are writing a separate function for this. Okay. That's what we are doing. And for calculating the new y also, we are writing new function. This one, new function we have. For this statement also, we have a new function. Okay, so this will give you an understanding of how to use functions. So here, if you see, everything remains the same. X is equal to 0, y is equal to 1. Its step size that you take is equal to 0.1, and you're doing it till xt. Okay, that is 1. This file open means if I want to save the values. Right now, it has not been displayed in a very elegant manner, right? Okay, it's been just scattered all the values. If I want to get it together in a single file, okay, then you can open a file like this. So when you're opening a file in MATLAB, first you need a name associated with it. It's not the actual name, it's like a variable name that you give. Okay, so file ID is a variable name for the file that you give, and you open a file. Fopen is a keyword that you use. The actual file name is Euler's experimental solution. Okay, Euler's EXP solution, and W means writing. Okay, that is you're opening a file with the writing permissions. That is you'll be able to write it further. Now, how do you write a file? Inside the file, this is the keyword fprintf. You're giving the file name. Okay, this is the variable name of the file. And what will be printed? It will be printed solutions using Euler's explicit method. And this \n means it will be a new line. Okay, so this will be the first line of your file ID. Then rest of the things is similar to what we did. We have a solution rather than just having it scattered. I'm just putting it together in a vector like this. So sol is a new vector which will have the x and y value. Okay. Now I'll be trying to printing it. For printing it, what I do again, I use fprintf. I have the file ID that is open. Now what am I printing it? I'm printing x and y value. So since x and y value are numbers, okay, you need to specify the type, data type in the file ID. So this I want to be a floating number. This also I want to be a floating number. So that this is how you mention it. Percentage F means it's a floating point. Percentage F means it's a floating point. New line means it goes to the next line. Okay. So then I am printing the sol. That is x comma y will be printed. I'll just run and show you how the output looks like. Now the next is, as I said earlier, for calculating the derivative, I am using a new function. Okay. So that function name is func_y. Okay. What all func_y does? Okay. Sorry. Yeah. These two has been combined. Sorry, these two lines has been combined. For calculating this, I'm writing a new function that is called as func_y. Func_y requires h, x, and y as inputs. So this is how the new function is. The function, as I said earlier, it starts with a keyword function. This is the output. This is the name of the function func_y. It takes in inputs x, and y. Okay. What does it do? It calculates a new y equal to old y plus h times the derivative, the Euler's explicit formula. Okay. So now it calls a new thing which is called as derivative. This derivative is another function. Okay. So this is the function derivative. It has a keyword function. It has an output variable. The name of the function is derivative and it takes in two inputs, x and y. This calculates the derivative as the formula given by here. This formula, the same formula here. Okay. So this is calling a function inside a function. So from here, func_y, it will go to here. And func_y calls derivative. So with x and y, it calculates the derivative and it's outputted here. dy by dx, you'll get it here. And the dy by dx is multiplied by h plus y, you get the new y, which is outputted here. And it goes to here, y1. Okay. Now, similarly, we are incrementing the x. We are reinitializing the y value, just like we did it here. Okay. Same thing we are doing it. Now I'll just run and show you how to do it. Just one more thing to highlight. So this is how you declare a function. Okay, the syntax is for declaring a function. But when you're calling a function, this is how you call a function. Sorry. Let me just okay. This is how you call a function. You give an output name, output variable for saving the output. You call by the function name and you give the inputs accordingly. Okay. So now let me just run this and show you. See, you will be getting several things, and your file ID is Euler's EXP solution. So that will be here in the command window. See, this is Euler's EXP solution. So this is how it will look like. First line will be solution using explicit Euler's method. See, solution using explicit Euler's method. This \n will take you to the new line. So this will take you to the new line. Here, x and y will be printed as a floating point. Okay. So that is why you can see a lot of decimal places, x and corresponding y, next x corresponding y, next x corresponding y. Like this, you will get it the answer in Euler's explicit solution. Okay. Now I'm just clearing it and I'll show you how does this work. Okay. Now again, I'm clicking on Euler's explicit solution. Okay. Now if you can see this Euler's explicit solution as a file. You want to access the values of this file. Now for that, what you do is you can take one variable name. Okay, it's just a variable name, and you can type load, and in this you can type Euler's explicit solution. Okay, this time name you have to take and close the bracket, semicolon. Unable to read Euler's explicit solution. What is the data type? Let's see. What is the problem? Have to just see. There is a problem in getting this data. Input must be a math file or an ASCII code. Let me just figure out what the error is, okay? I'll just figure this out, but let's not waste the time. Okay, other than this, do you have any other doubts?
No, ma'am.
Okay. Apart from this, there is also ODE solvers, which I'll come to that later. Okay, before that, I'll just give you some questions so that you can work on it. Okay. So we have a codes for showing ODE solvers, and we also have a plotting. Okay, and better I show the plotting one, and ODE solver I'll do it later. Okay. So imagine you have an experimental data like this. This such data you'll get it in your lab. You have your t values, and corresponding from experimental one you have a data values. Experimental two you have data values. Okay. So this experimental one is trying to fit a model, and the model function is y equal to cos x. And the experimental 2 is trying to fit another model function, and the function is y equal to e raised to minus x. So now imagine you have to create graphs for your paper or something. Okay, for your project report or something, you have to create graphs where you have to plot your experimental values, and you have to also plot your model values to see if your experimental values are matching with your model. Okay, so for that, you will be using a plotting function. How do you use a plotting function? I'll just show you here. Just a second. Yeah. So first you have to save your experimental data like this. Okay. Whatever is given. Sorry. Uh, that's yeah. First of all, you have to save your experimental data like this. Okay. The first column is all your the time, and then you have your experimental one values, experimental two values. Okay. You have it like this. And run this. You are getting it like this. Okay. This is your experimental data. And then you want to plot it from x is equal to 0 to 1. This is because your x value is ranging from 0 to 1. Okay, model can be having a final grid also. Here the step size is 0.1. Okay, so can take a 0.1 or 0.01. You can take a final grid also if you want to. And your model 1 is cos x. So here x value is 0.1. When you're doing cos x, what will happen? So here you can see this is your x values ranging from 0 to 1. And model 1 cos x means every values cos will be taken. See? So this is cos 0.1, this is cos 0, cos 0.1, cos 0.2, like that you'll be getting. Similarly, model 2 will be exponential 0, which is 1, then exponential of 0.1, exponential of minus 0.1, exponential of minus 0.2, and so on till exponential of minus 1. Okay. Now, just give me a second. Okay. So likewise, you have right now the two models. You have the x values and the model values. Now we need to plot everything. Okay. So for plotting, I think last week I had shown you plot is the keyword. You have to give the x value and the y value of the plot you want to do, and then you give specifications like which kind of marker you have to use, which kind of line you have to use. You can also specify the colors you want and everything. Okay. So right now what I do is I use plot is a keyword. I want to plot the experimental data. This experimental data has three columns, out of which I want to plot the first values. So this is my x-axis. Experimental, all the rows, first column. That's what it means. All the rows, first column. Okay, that is my x-axis. What is my y-axis? Y-axis is this column. So that is all rows, second column. Okay, all rows, second column. That is this values. Then it has to be all circles. This is called as markers. And the marker size has to be 10. And the marker color has to be R. R stands for red. Okay. Now, hold on. Since I have kept hold on. Hold on means what happens is when I'm using a plotting function, the first plot will be on a figure. Okay. When I'm again using plotting, it will be on a second figure. It will be two separate figures. Okay. So, but if you use hold on, what happens is you will be getting every plot in a single figure. Okay. That's what hold on means. Okay. So if you're just using plot, what will happen is you'll be getting multiple figures. Here in my case, I want all the lines to be on the same plot. So I'm using this hold on command. Okay. That means hold on to the first figure itself and keep adding it to that. Okay. Hold on. I'm plotting the first experimental data. This is my second experimental data. X-axis values are the for all rows first column and y-axis values are all rows third column. And here I'm using S means square markers. Okay. Marker size is 10. Marker edge color is blue and marker face color is blue. Okay. This you'll understand after plotting what it is. And now I'm plotting the model. So the first model X values are this. Okay. And Y values are this model 1 values. Now I want it to be dotted lines. And line width is 3 and the color is magenta. M stands for magenta. And my next plot should be X values is this. Okay. And my model 2 is exponential minus 1, minus X. Okay. Model 2. Line width, this, if I don't specify anything in a line plot, I'll be getting solid line. Okay. But the line width should be 2 and the color should be K. K stands for black. Okay. B is for blue and K is for black. Okay. Please keep that in mind. And now these are some variables. I'm fixing my x-axis and y-axis values. So x-axis should vary from 0.1 to 1.1 and y-axis should range from 0.25 to 1.05. Okay. And my font size, all my X label and Y label font size, I'm fixing it to be 40. Will be my X label. It will be printed in my X axis. That is distance from the surface. And my Y axis, this will be printed normalized temperature. Okay. Hmm. And these are some legends. This is how you add legends. Okay. This is my first legend, second legend, third legend, and fourth legend. This will be understand. After plotting all the 4 plot, I keep hold off. Okay. Now let us see what this actually does. I'll just run this here. Okay, this is what you get. You get the x-axis here, distance from the surface, y label here, normalized. Okay, this is the how my values range. Okay, the x-axis and y-axis I've already said. It has to be from minus 0.1 to 1.05. And this values ranges from 0.25 to 1.05. Okay, now all the font sizes are 14. And my legends, if you see, my first line will be system 1, second line will be system 2, third line will be model 1, and the fourth line will be model 2. Okay, now coming into the lines. Sorry, just a second. See, my first has to be circles. Okay, and marker edge color should be red. So these are the circles. You can see this is not filled circles. Only the edge color is red in color. Okay. Next is second should be squares and it should be having filled ones. So you can see filled blue squares. And now my model 1 is dotted lines and that too in magenta color. And the last model should be black solid line. So now we can see this blue one is matching with your, the trend is matching with your black one and your red dots are matching with your magenta line. Okay, so your experimental data is the trend is similar to the model that you expect. So this is how you create graphs for your project reports or something like that when you want to present your results. Is this clear? Do you have any doubts how to use plotting function?
How did you make these like define these system one, system two? How do you show these on the
So
left and
on
right hand side
this
at the
side,
bottom at
this
the
hand
top?
side.
Is
Okay,
that
this is called as legends. Okay, adding this on the left hand side is called as legends. So for that, there is a keyword which is called as legend. Okay. And then what happens is I have here 4 plots now. According to the order, this legend has to be placed. So whatever my first plot is, that will take this name, system 1. Whatever my second plot is, it will take the name system 2. So I am the one writing the code, so I should be giving this legends in proper order. Okay. My last third one is model 1, so I should be naming it as model 1. And my last one is model 2, I should be naming it as model 2. This I specify. Box off is a command that I can show you. Box off means This will not, there will not be a box around it. I can show you. If you don't give box, if I'm just commenting the statement of clear, if you want to close an image, the image is close all. Okay, this is if you want to close an image, that image is gone. Okay, again, I'm using plotting. See, you will get a box around it. Okay, so this is the legend one. This is what gets printed here. You can give any name. You can give system one or experimental one or experimental two. Any name can be given. But the MATLAB doesn't know what each graph is, right? So it's according to you that you should give the names, right name, meaningful names in the right order. Okay, this you can give it like here. This is the command legend.
Okay, ma'am.
Okay. So that's it. We'll come to the ODE solvers if we have time, or else we can take it up in the next lecture also. So right now I'll just give you few questions and I'll give you few minutes. Okay. So I want you to do is, if I just keep giving you answers, you'll not keep thinking. So even if when I'm giving you the recorded lectures, I want you to take some time. If you have MATLAB, try coding it. If you don't have MATLAB, you can just write down in a pen and paper the basic logical statements. Okay? Because in this whole
Okay.
course, just listening to me will not help. You have to actually write codes. Okay? Only then you will understand the mistakes and everything. So I'll just give you uh, few problems so that you can brush up your skills. And I'll just pause for like 2-3 minutes so that there is enough time for people in the live session, and also for the people who are watching the recorded session can actually take some time and answer this question. Okay.
Okay, ma'am. And for this first problem, I need to make the code. I need to write the code for all these
So
four
this is
questions.
what I've taken is some of these questions are taken from assignments. Okay. So in your assignments, you might have multiple choice questions. Okay. So this is like maybe a multiple choice question. For this first two question, you don't have to write a code, but the last thing you have to write a code. The code means you have to write a one-line statement, how to extract. It's just a
Okay.
one line. Okay. Not a whole code as such. If you've got answers, you can put in the chat box also, okay?
Okay, ma'am. Ma'am, for the sum question, the answer is 0, and for the second question, the rank 1, and the answer is 2.
Okay, yeah, the next two also you can try to write the statements, okay? And then we'll discuss. Yeah.
Done, ma'am.
Now we'll discuss the answers. So the metrics, so first let me just share MATLAB. Let me just close all. Okay, here, PLC. So this is a matrix you have. Okay, this is the matrix you have. Now we have to calculate the sum. Sum already the command has been given to you. It is like sum from 1 to the nth rows, but you have to increment by a step size of 2 and then only the first column. Okay, answer that you get is 0. Okay, and the next is rank. Rank also automatically MATLAB calculates for you, but what it has been extracted, it is extracting first two rows and second and fourth column. That is first two rows, but only the second and the fourth column. That is 2, 1, 4, minus 2. If you want, I can just show you this one alone. So it will become, okay, 2 to 4. Sorry, not 2 and 4. It is 2, 3, 4. So it will become 2, 3, 4, 1, 3, minus 2. Okay, and rank is what? We'll say rank is 2. Okay, these two are like independent to each other. So you'll get rank equal to 2. Now you are extracting certain elements of a vector, certain elements of this matrix. So it will become second row and all the columns from 2 to n. Okay, all the second row is this, and all the columns means it will become 1, 3, minus 2, minus 1. Let's see. Yeah, that is you're getting 1, 3, minus 2, minus 3. Okay, that's how you 1 minute. What was the question actually? Let me just go back. Uh, sorry. Yeah, the question is you have to indicate this one, extract this one. So this is the second row, and the column is column is 2, 3, 4, 5. So whatever you have given in the, yeah, 2, 2 to end. Yeah, that is right. Whatever you have answered is right. And next is you have a submatrix that is minus 1, 0, minus 3, 2. So what are the row numbers? Row is 3 and 4, and column is 1 and 2. Okay, so that will be column 3 and 4, and so we'll just, okay, I'm just taking our answer from the chat box and we'll just run it and see. Okay, so yeah, you'll be getting minus 3, 0 and minus 3, 2. Okay, so the answers are right. I hope that is clear. Now we'll move on to the next question. So this is just, I'm just showing you an example of a rank, okay? So here you can see the first row and the second row are related. So if you multiply 3 to the first row, you get the second row. Only the one independent row is there, so rank is equal to 1. Here also you can see if you multiply, if you add the first two rows, you get the last row. So the independent row is first row and second row are independent, so rank is equal to 2. Okay. Here also you will get the row 3 can be expressed as a function of row 1 and row 2. So the independent row is row 1 and row 2. So the rank is 2 here. And if you have an identity matrix, sorry, here it's not visible, rank is equal to 3. That means no rows or no columns are dependent on each other. They are linearly independent. Okay. So that is why the rank is equal to 3. Okay, this is just an example to show you how rank of a matrix is calculated. Now this is the next problem. You can try solving it and I'll discuss the answers in few minutes.
Okay, ma'am. Okay, ma'am. Ma'am, I'm not able to get this answer. Can you please tell me?
Yeah. So we'll just explain this one. Just give me a second. See here you have a vector t. It ranges from 0 to 4 with the step size of 0.5, where t is a number of years and a radioactive element decays. This is a function. Okay. We have a function nt. So here basically it starts from n0 e raised to minus t by 2. This is a function. Here n0 is a constant that is equal to 1. Tau is also is equal to a constant 2. So now here the only unknown is t, and that t is also given to you. So you get n as a function of t. Rest everything is known, n0 is known, tau is known. So basically, you have to first calculate what is n, and then you have to plot it. How do you plot it? You have to plot it like this. It has to be solid red line with blue markers, circle markers. Okay. So first, let us try to code this one, and then we'll plot it. Okay. The function is n0 e raised to minus t by 2. Let's go to the code. Clear CLC. Yeah. So first, t should be ranging from 0 to 4 with a step size of 4. Okay, that you already know. And 0 is equal to 1, tau is equal to 2. Now you code this n is equal to n0 exponential of minus t by 2. Minus t is, or it takes individual value. Okay, so minus t divided by 2. So first, basically, you'll get values like this. Okay, where t is this and n is like this. So corresponding to every t, you'll get a n value. Now, how do you plot it? For plotting it, you have to plot like this. Okay. See, so this is a simple trick actually. Uh, so first I'm plotting all the t. This is the x variable and this is the y variable. And I'm saying that it has to be a line plot. It is a line circle plot. Okay. Line circle plot with a red color. Okay. This is one way to do it, but you know that instead of red color, it has to be blue color circles. Okay. So what do you use? This is the actual command, right? You have to use t, x, and y values. It has to be a line circle thing with the red color, but the marker's color I'll change it to blue. Okay, this is explicitly I'm writing it. So what will happen is I'm just typing hold on. Okay, hold on, and I'll run this command. See, now we can see the marker. So it first it was completely red, but when since I gave marker edge color, all the markers color will change into blue. Okay, so this is how you use that plotting command.
Okay, ma'am. Got it.
Okay, now moving on to the next question. Okay, take some time and let's give time in the recording also. Then we will discuss answer. Okay, if you have answers already, you can put it in the chat box.
Okay, ma'am.
We'll take 2 more minutes after that and discuss.
Ma'am.
Yes, you've got the answer. Okay, we'll see that. Okay. Yeah, I saw your answer in the chat box. Now we'll go see. So we have your three vectors, D1, D2, and D3. And we need to create a final matrix D in such a way that D1 is in the main diagonal, D2 is in the first upper diagonal, and D3 is in the second lower diagonal. Okay, so we'll do that. Let me just clear all this up. Clear. So So this is already D1, D2, D3. So first, whatever you, I think, yeah, whatever you did, it is actually right. You have got it right. Okay. Now I'll just quickly explain it. You have all the vectors written. Now we'll make a vector A in such a way that D1 comes in the main diagonal. So that is this. Um, okay, sorry, I have to use this first. Okay. You can straight away run this also, but I'm just showing you step by step. Okay. Now we will run the A equal to diag1. You get a matrix with entries in the diagonal entry as D1. Then in the upper diagonal, you require B. So this will be a matrix with entries on the upper diagonal is -3, -3, -3. And in the lower diagonal, you require -1, -1. So that is why -2 means second lower diagonal. Okay. Since all the entries are 0, okay, you can just, what you can do is you can just add this matrices. Okay, because other entries are 0. There is no overlapping entries. So you can just add these entries and finally you will get A plus B plus C. You will be getting the entries in such a way that in the main diagonal you have 2, 4, 6, 8. In the upper diagonal you have -3, -3, -3. And in the second lower diagonal you have -1, -1. Okay, whatever you've written, Karthik, right? Yeah, it's right. Yeah, good. Now we'll move on to the next question. Let me just share the PPT. So this is the next question. You have to write a code for calculating R is to N for N equal to 10, 50, and 100 and display their sums. And R value is 0.5. Okay. Maybe it can be like a 2, 3 lines of code. You can try to.
This is a summation, right?
This is a summation. Yeah, it's a
Summation.
summation. Yeah.
Okay. Yes, ma'am.
Now we'll have this. We'll see the final answers. So R raised to N. Okay, N equal to 50, 10, and 100, and our R is equal to 0.5. Let me just show the code. So we have to write, you can write it separately also. Right now, I'm just showing you how to do it directly, okay, using vectors. So the one key advantage of using MATLAB is MATLAB gives you a lot of flexibility. A lot of operations can be directly run in on top of vectors and arrays. Okay, you don't have to write like long lines of code. So here you can see n equal to 100 and I'm typing n. First, what I'll do is I create a vector of powers. Okay, you know, R is a constant value. R is 0.5, you know, and n has to go from 0 to 100 or 0 to 10 or whatever it is. 0 to 10. I think first is 10, 50 and 100, right? First, let us do for 10. Okay, so first I'll create a vector of the powers. So it will become 0, 1, 2, 3 till 10. My R value is 0.5. Then what I'll do is I can do vector, sorry, element-wise exponential. That is dot exponential n. So this will become 0.5 raised to 0. Then will be 0.5 raised to 1. Then will be 0.5 raised to 2. So until 0.5 raised to 10. So that values will be there in the answers values. Okay, that vector will be values. And finally, I'll get just use sum. Okay, to calculate the sum of values. So I'll just print it for you. Okay. Just print it for you. So here you can see values are like this. You can see R is equal to 0.5. R is 0.5. Small n is a vector that is 0, 1, 2, 3 and so on. Okay. And now you have values that is R raised to 0, R raised to 1, R raised to 2, to 1 till R raised to 10. Okay. Then you calculate the sum. So the sum is actually 1.999. For what was the question? Question was for, sorry, 10, 50 and 100. Mm, okay. I think I'm sharing the MATLAB on this. So that will become 1.999. One mistake you would have already, there is high chance of doing is you need to start from 0. Okay, if you remember in the summation, it starts from, I'll show you the code again, sorry. See, it starts from 0. So R raised to 0 is there, which is 1. Okay, so that addition of 1 is important. If you had started from 1, it will become R raised to 1, R raised to 2, R raised to 3 till R raised to n. So R raised to 0 is missing. Okay, so that will be a problem. So just make sure you just include 0 also. So then your final answer will become 1.9999. Okay, so now if I want to do it for 50, just change the n value. Okay, and how to display it? I can just display this is sum, this is the vector I want to display, and then the sum value, since it's a numerical value, I have to convert it into a string. So the command is num to str. I keep the numerical value, and finally I'll print it here. See, like this. So I'll just clear it and run it again. CLC for 10. I'm just clicking here, and I'll run the section. See, sum of value is 1.99. For I equal to 50, again the answer will be sum equal to 2. And for r equal to 100, the sum will be equal to again 2. Okay, so that's the answer. Okay, and again you have a loop here. You can do the same thing using a loop. Okay, so that is r is fixed and sum is equal to 0. Instead of like manually going and changing this, you can put this set of commands inside a loop for n equal to 10, 50 and 100. What happens in the first loop, it will go from n equal to 0 to 10. The same commands will come. Okay, so instead of running this step by step and manually changing it, I can just put the whole thing, this whole thing into a loop, just that the n value has to go from 10, 50 and 100. Okay, I'll run this section. Did I make a mistake here? Some values, array indices must be positive, right? Oh, only this much is required. I think there's an error in this code. 9:15. Why is there an error? Just unmute yourself if you don't have anything to say. Karthik, can you just unmute yourself? Yeah, thank you. So here, root as a function and as a variable. Am I using some? Oh yeah, sorry. This is because it has been from here like this. Mm, Yeah, this is unnecessary. I don't know what to do with this. I use the same variable. Sum is an inbuilt MATLAB command. What I did is I used that also as a variable name. Okay. Transaction, you'll be getting like this. I'll just comment this out. Sorry, put a semicolon. Run the section, you'll be getting same thing. 1.1.992 and 2. Is this clear?
Yes, ma'am.
Yeah, okay. I'll just share the next question. Okay, I'll give you some time. Let me just take a break to drink some water. Okay, and then we'll discuss the answer. Okay, and I'll come. Okay, we'll discuss the answers right now. So this you have to draw a unit circle with the center 0, 0 and draw a circle with the center. Next question is draw a circle with center 1, 1, 2 and the radius should be 2. Here it should be radius equal to 1 and here the radius is 2. The thing is you have to, if you remember, you can draw the circle if you have the theta values. Okay. So we'll just quickly go to the code. That is a hint that has been given. Mm, okay. So here what happens is, if you remember, if you have a theta value that is ranging from 0 to 2 pi, cos theta and sin theta will give you the x values and the y values for drawing a circle. So this is like from the basic math which I have learned. So what happens is I take theta values from 0 to 2 pi with a very, very small interval 0.011. This has to be very small, only then you will get a very smooth circle. Okay, let me just clear this first. Okay. And then what happens is I have a theta value, I have like cos theta, sin theta, and I can directly plot it with a solid red line. So I'll just run this section. You'll be getting a circle like this. Okay, this is a unit circle. But what if you want to shift your center and also increase the radius? What do you do then? Then if you remember in maths, you have learned this formula. Okay. Your center, if you want to shift, you have to add that. So your 1 and 2 is your center. So it should be 1 plus cos theta and it should be 2 plus sin theta. Okay. You're shifting your center to 1 comma 2 and your radius has to be multiplied. So your radius has to be 2. 2 is multiplied here. So now you will get a different circle with center 1 comma 2 and a radius 2. Okay, I'll just run the center. So this is a formula. Center is hk and the radius is r. Then x will be equal to h plus r cos theta and y will be equal to k plus r sin theta. And finally, you'll get this like this.
Okay, ma'am. Got it. Ma'am, you will be sharing these codes on the NAPTEL portal, right?
The codes will not be shared, but the recordings will be shared. I'm not sharing the codes because then you'll just copy paste it. So I'll be sharing the recordings with the codes in it. You can just look at the recording and type the code by yourself. Okay.
Okay.
I'll just show you the next question and just give me some time and discuss the answer. Okay. So this is the next question. I'll just give me some time. Okay. I'll explain this answers. So coming to the answer of this question, we need to Can you hear me? Am I audible?
Yes, ma'am, you are.
Yeah, sure. Okay. So we need to generate random temperatures between 15 and 30 degrees Celsius for a month and calculate the average temperature of it. Then you have to display the days which has temperatures above 25 degrees Celsius, okay? And calculate and display the day which has the highest temperature. So for generating random, you can use the inbuilt MATLAB command, which is rand. We'll go to the code. So this is just a lengthy code, but the main idea is you need to understand how to use the MATLAB commands. Okay, so if you take help rand, oh, sorry. Okay, I hope you can see the MATLAB. So random numbers usually generate n by n random numbers with the interval 0 to 1. Okay, so all the random numbers you generate, though it is random, it will become 0. It will be between 0 and 1. What if you want to generate values between, here it has been said that it should be between 15 and 30 degrees Celsius. Okay, that is now the interval has changed. Then if you need to create random numbers, this is the command. Okay, if you need to create random numbers between the interval a comma b, this is how you create. R is equal to A plus B minus A random. This is the number of numbers, how many items you want, 30 or something. Okay. So here in this case, your A is equal to 50, B minus A, 30 minus 50, multiplied by rand, you just need 30 entries. Okay. So it is a rand 30. Okay. So now you get, if you use this command, you will be getting 30 random numbers that are ranging from 50 to 30. Now we need to calculate the average temperatures. Okay. So basically you have to just calculate the average. You can directly sum and divide by the total number of entries, or else just like sum is a inbuilt command in MATLAB. You also have an inbuilt command which is called as mean in MATLAB. You can use that also. Okay. So this is the average temperature. Now you can display it. This displaying command, I think by now you would have understood the displaying command. Okay. The average
Yes, ma'am.
temperature for the month is, you get it in degrees Celsius. Okay. Now you want to identify the entries which are greater than 25 degrees Celsius. So that also you have an inbuilt MATLAB command. That is your threshold. Okay, I'm just declaring a variable threshold is equal to 25, and my new variable is above threshold days. So the inbuilt MATLAB command for that is find. Okay, what you do is find, you give the whole vector and greater than threshold. What it does is it will only give you the indexes of the days which has greater than threshold value. So for example, threshold is equal to 25 and above threshold, we'll just execute this command. Okay, so you get 2, 3, 4, 7. This means your second entry is greater than 25, third entry is greater than 25. We can just confirm here. What is your second entry? First entry is not greater. Second entry is greater than 25. Third entry is greater than 25. Fourth entry is greater than 25. But fifth is not. So is 5 here? No, 5 is not there. 2, 3, 4, 5 is not there. So you get the indexes which satisfy this condition. Okay, that's what find does. Okay, now we have to display. This is days with temperature above 25 will come, and you will get the number of days here. So I'll just display here. You get it like this. Days with temperature above 25 degrees Celsius are 2, 3, 4, 7 these days. Okay. Now we want to calculate the maximum daily temperature we have. We need to calculate the maximum daily temperature and also the day which that occurred. Okay. So for that, you can use the inbuilt command max. If you're directly using this inbuilt command max, what it happens is it directly calculates which is the maximum temperature, that is 29.85. It doesn't give you which day it happened. It doesn't give you the index where this maximum is there. So if you want to get the index also, you can just see here, help max. If you go here, you see that if you just type max, you get the largest element of a vector. Okay. But if you're also returning the index, if you need the index corresponding to the maximum value, then what you do is you type max, but here you should have two outputs, one for M, one for index. So the first output will be your maximum value, and I will store the index which is corresponding to it. So this is what we require here. So what we do is we type max temperature, max day is equal to max daily. So here the output will be like this. See, max temperature is 29.85 and it happens on the 23rd index, that is 23rd day. So you can display the command here. You'll be getting day with highest temperature is day 23 and that is 29.8508 degrees Celsius. Is this clear?
Yes, ma'am. Ma'am, but
Yeah.
why do we didn't use the random integer command here?
That is here.
Ma'am, this is the R&D. I'm going asking about R&DI.
R and DI just gives you integers, right?
Yes, ma'am.
1 minute. R and DI 10. What do you get? So what is this? 1 minute. L and DI. See, that is different from R and DI is a pseudo-random integer with uniform discrete distribution. Returns n plus n pseudo-random integers drawn from a stricter uniform distribution from 1 to I max. Oh, sorry. So the index I gave it wrong. Okay. So just give me a second. Uh, uh, 10 comma 5. What does it happen? It gave me a 5 plus 5 matrix whose maximum value ranges from, see, it gives you integer values. I need points also, right? You don't get values like this for 25.8, all those things.
Okay, ma'am.
Yeah. And also the random integers, the randi works a little bit differently. You can go to here and see. Okay, it creates an n by n matrix. I don't need n by n matrix. I should require a vector also. Using using a rand, you can create a matrix also. Okay. If you have given 30 by 30, you'll get a 30 by 30 matrix. But if you give 30 comma 1, you'll get a vector also. But here it is an n by n matrix. I don't know if we can create a vector out of it. And also, right, in this case, we also require numbers. Like we just not just integers, we require floating points also. Okay,
Okay.
that is why. Mm. So yeah, this is an example. Let me just quickly show you the solution for this, okay? Because we don't have enough time. Next week, in detail, we'll take ODE solvers also, okay? We'll start with ODE solvers and then we'll go to the next sections. Just
Okay.
a second. Because ODE solvers will take some time for you to understand. If you're newly introduced to the ODE solvers. So here you need to generate X values with 20 equidistant points between 10 and 50. Okay, and F is log AX, where A is 10 and 20. You need to plot the both functions in a single plot. Ensure that the plot is properly labeled, including titles and axes. You can use cell array to give proper legends. That is fine. Also calculate the mean of both functions. I'll just show you the code right now. So what happens is you need values ranging from 10 to 50, 200 equidistant points. From that itself, we can understand you should be using linspace because 200 points you have to generate. Don't have time to sit and calculate what should be the step size from 10 to 50 for getting 200 equidistant points. So you have X values, linspace 10 to 50, 200 equidistant points, and A value is 10 and 20. Your first function value is log 10x. So it will become log A1 means it will take the value of 10. If this is actually not required, you can directly type log 10x. Okay, that is also possible. Okay, you can directly type log 10x and this will be log 20x. We have two functions. Okay, how do you plot? You have first plot. You have the X label and Y label that is given. That is, it will become X and F1 will be typed. Then you hold on to the same plot the second plot, X and F2. Okay, this is what is called a cell array. Okay, Bhakti type legend is usually typed in a curly bracket, and this in MATLAB, whatever you type in a curly bracket is called as a cell array. Okay, so legend, whatever we did earlier, you can directly type A equal to 10, B equal to 10, and that comes, you can directly type this here also. Okay, you can directly put it here also inside this legend bracket also is the same. And the title of the graph will be logarithmic functions. Okay, that is one thing. And then they have also asked us to plot the sum of these two functions. So that can be plotted in a different graph or the same graph, whatever you wish. How will you plot it? X and f1 plus f2. You can just directly add it in the plotting function itself. If you want to have a separate variable like sum equal to f1 plus f2 and plot that sum, that is also fine. So let us first run this section. Okay. So this is a first plot. Okay. For a equal to 10 and a equal to 20, you get two plots here. And if you add it up, you get a single plot. Okay, that is the second figure. Why second figure? Because I typed hold on, type hold off, then I gave plot. So hold off means that hold on, that structure is gone. Now you go to the next figure. So that is why my second one came in the new figure. Now how to calculate mean? Mean is also already known to you. You can directly type mean of F1, mean of F2. Okay. So this is something called as Matlab structures, not very important. Like right now, at this point of time, it's not very important. You can directly type mean of F1 and mean of F2. You'll be getting the mean. Okay. If you want me to execute this statement and show you, I'll show you. Structure is a different way. It's something different, but similar to arrays. Okay. So it'll look like this. F1 mean is this, F2 mean is this. Okay, you can go search for structures if you want to invest more time in this, but at this point of time, it's fine. You have to know what structures is. But the what important thing is you need to know how to do some basic coding in MATLAB. Now moving on to the next question. This is the last question of the day. Try to solve this problem. You can use matrices. I'll just give you a hint. In maths, we have tried to solve problems like AX is equal to B and X is nothing but A inverse of B. Okay, that's what we have to use right now. I'll give you 2 minutes and then we'll discuss answer. Should I explain the answer right now? Or do you need more time?
Now you can explain.
Yeah, okay. So here you have like three equations and three unknowns. So you have to create a matrix in such a way that you will get it AX is equal to B. Okay, so first for that, let us create a matrix. Okay, so AX is equal to B means A will have all the coefficients of X, Y, and Z. So that has to be properly written. So if you remember, you have to slightly rearrange this equation. So all the 5, it will become 5x minus 3y plus 2z is equal to 10. And this one will become minus 3x plus 8y plus 4z is equal to 20. And this will become 2x plus 4y minus 9z is equal to 9. Sorry. And then you will have to write the coefficient matrix. That will look like this. Now your B matrix, that is a B matrix for the constants. So that is 10, 20, and 9. So now you have let me just clear it. Okay, now we have got the A matrix and the B matrix. Okay, now how do you calculate X value? So in max, you have understood that if you have a matrix like this, if it is in the form of AX is equal to B, X is nothing but inverse of A multiplied by B. So in MATLAB, already there is an inbuilt function for calculating inverse, which is INV. So you do INV A multiplied by B. Okay, so this is a function that we have. So x is equal to 3.442, 3.1989, and 1.1868. Okay. So one tip I have to say is that this inverse function in MATLAB, um, though it is an inbuilt function, it is a slightly heavy function. Okay, it is slightly computationally expensive. For simple matrices and all, you won't figure that out. But when you're working with large matrices, this can be slightly more computationally expensive. So for that, there's another alternative. That is, instead of typing inverse of A multiplied by B, you can do A backslash B. It's not the other slash, not the normal slash that we use for division, not that. It has to be A backslash B. Okay. So when you're dealing with large matrices, when the size of A is large, you can use this one, A backslash B. This is more efficient than inverse of A multiplied by B. Okay. You will get the same answer. You'll get the same answer. Okay. So not the other slash, you have to use backslash, A backslash B. It is same as equal to inverse of A multiplied by B. Okay.
Okay, ma'am.
Okay. So that's it for today's session. You can go through the recordings, and if you have doubt, you can come up in the next class also. And I'll upload this as soon as possible. Probably by today, I'll upload both the PPT and the recording. Okay.
Okay, ma'am. Thank you, ma'am.
Yeah. Thank you so much.